In this video, we're going to look at graphing y equals, or f of x equals -3 secant x plus 1. Now, there's some little tricky parts in here, so you might be thinking, hey, first thing I want to do is start off and graph f of x equals -3 cosine x plus 1. Well, you're partially right, okay? You're partially right about that. One thing we're going to have to be really careful about is this vertical shift. So let's first start off and just graph f of x equals -3 cosine x without the shift of plus 1 and talk about the asymptotes. All right, so cosine, let's see, cosine usually starts at 1, right? And then goes down 1, let's say that's 1, it goes down and back. Okay, the period here is still 2 pi, right, because we don't have anything times x. The negative here is going to flip the cosine over, so instead of starting high and making a big valley, it's going to start low and make a big hill for the period, and it has an amplitude of 3, so it's going to go from 3 to -3 even before we shift it. So once we shift it up 1, it's going to be going, instead of going from -3 to 3, it's going to go, so instead of going from -3 to 3, when we shift it up 1, it's going to go from -2 up to 4. And then we're still going to have to do the secant, which, remember, is like on top of it and below it. So I'm going to have to think about my scale here a little bit. I don't really want to make each of these worth 1, because I know the cosine is going to go all the way up to 4, and then I'm going to have to do the secant. So maybe we make each of these worth 2. Kind of thinking ahead and planning out your scale is important. Let's make each of these worth 2. Okay. So the period of our cosine is still 2 pi, and we have an amplitude of -3, so an amplitude of 3, -3, which flips it over. Actually, the amplitude is 3, and then the negative flips it over. Let's do this in red. So we're going to start at -3, and when we finish, we want to be back at -3. Halfway through, for cosine, we want to be at the maximum of +3, halfway through the period. 1/4 of the way through the period, we want to be at 0. And 3/4 of the way, we want to be at 0. So let's go backwards and fill these points in for negative values. So at -pi, we're going to be at 3. This is before the shift, right? Even before the shift. We're just doing this part. And there's a reason we need to do that. Okay, then this is going to go here. All right, so let's sketch this cosine graph before the shift. Alrighty. Now, the reason that we have to look at this before the shift is because the asymptotes for the secant function are determined by when the cosine is 0 before the shift. So let me say that in a different way. If we think about when this is going to be undefined, it's going to be undefined when the secant is undefined. And that's going to be undefined when the cosine is 0. Now, certainly if the cosine is 0, all of this bit, if I multiply it by -3, will also be 0. Once I add 1 to it, it's not going to be 0 anymore. So I really need to just look at this piece, this red piece. Let me jot down for clarity what this red piece is. This is just y equals -3 cosine x. So when that's 0, that's when we're going to have our asymptotes. We have to figure out the asymptotes before we do the shift. That's the key here. Because once I shift it up 1, I'm going to have different x-intercepts, and those x-intercepts are not going to correspond to the asymptotes. Let me show you that visually using Desmos. Okay, so in Desmos here I've got a cosine x plus b. So for the problem that we were doing -3, our a value is -3 cosine x plus b, and we just graphed -3 cosine x, so without a vertical shift. So that's this red part. That's the same red part we have. Oops, that's the wrong one. There we go. That's the same red part we have over here. Okay, it's just prettier because it's in decimals. All right, here we go. Back to decimals. Now, I'm going to put the secant graph up here. You ready? That's the secant with the same a and b value. Remember, that's what the secant's going to look like. And if I look right here, I can see that these asymptotes looks like pi over 2, negative pi over 2. Let's put those in real quick. X equals pi over 2. Let's make that dotted. And x equal negative pi over 2. There's other ones, but well, there's infinitely many, right? Negative pi over 2. For the sake of time, we'll just look at these two. Okay. So now if I take my graph, my b, this b value, I'm going to change it from 0. It's at 0, so it's not doing any vertical shifting so far. I'm going to move this b value up. Now I want you to watch both graphs and the asymptotes. You ready? Here we go. Aha. Aha. See, it's just moving it up and down in these asymptotes right here, between these asymptotes. I really want to make one more asymptote. Let's do x equal 3 pi over 2. And we'll make that red and dotted. Okay? So see what I mean by you have to determine your asymptotes before you do your shifting. That's very powerful visual there. Okay, let's go back over to our thing then. So that's why we had to determine our asymptotes before we do our shifting. So now we can go ahead and graph the -3 cosine x plus 1. Okay, so after I do my asymptotes, then I'm going to shift this up 1. Up 1. I'm just shifting my cosine up 1. Oh, wait, that's not 1, is it? This one. Because we did a scale of 2. Up 1, up 1, up 1. Okay, now I'm going to draw that cosine graph in here. And then from this cosine graph, I can do the secant graph. So maybe I'll erase this one. I'm kind of scared to do it. Let's do it. Let's be brave. Okay, so I'm going to erase that one. I used that one to determine my asymptotes because look, now that I've shifted it up 1, this is where the x-intercept is, but this is not an asymptote. Here's the x-intercept, but that's not an asymptote because the cosine is not 0 there. The cosine is 0 before we shifted it up. All right, but now that we've got it shifted up, now we can go ahead and draw our whole secant graph here by using these U-shapes between our asymptotes. Okay, so
I didn't get that.
Oh,
could you try again?
Okay, my watch is talking to me.
I'm not sure I understand.
Is that you guys out there in video land? She said, I'm not sure I understand. Hopefully you do understand. Okay, so the big takeaway here is we have to, when we have a vertical shift with secant or cosecant, we need to determine our vertical asymptotes before we do our shifting.